The first thing you want to do when looking at word problems is make sure that you understand what's being asked. So when you read through the problem, you want to pick out the important information. In this case, a farmer wishes to enclose a rectangular area using 340 meters of fence. The farmer is going to use the river as one side of the enclosure, and you want to determine the dimensions that will maximize the area, as well as find the domain and range of the area function. The next step, once we understand the problem, is to draw a picture representing what we have. So here's the river, and the farmer is going to build a fence that's a rectangular fence, and it's going to use the river as one side. So let's label, this is the width of the river, or the fence, sorry, and this is the length of the fence. Once we've drawn our picture, we can collect all of our information. We know that the total amount of fence used is 2W plus L, because there's two widths and one length. And we also know from the problem that the total amount of fence is 340 meters. The other thing we need to find is the area, and we know that the area of a rectangle equals the length times the width. However, this doesn't quite help us because we still need to find a way to relate everything together. We can rearrange this relationship here to find the length in terms of the width, which is 340 minus 2W, and then we can use this information here to put into our area function. So we get our new area function, A equals LW, which equals 340 minus 2W times W. If we expand that, we get 340W minus 2W squared, which is a quadratic. Now we can rearrange, and put it into vertex form by completing the square. So first thing we do is factor out the 2, get W squared minus 170W, W squared minus 170W, then we add half squared, so negative 35, 85 squared, and then we take away negative 85 squared. That gives us negative 2, W minus 85 squared minus 85 squared. Then we can expand it out and factor and multiply by 2, so we get negative 2, W minus 85 squared plus 14,450. So let's look at this final equation that we have for area and see what it tells us. So because it's in vertex form, we can read the vertex right off of the equation. So our vertex is going to be 85, 14,450. So what does that tell us? It tells us that when W equals 85, the area is maximized and it equals 14,450 meters squared. So we've answered the second part. So our dimensions, therefore, are 85 meters by L, and we need L because this is W, and L we said equaled 340 minus 2W, which equals 340 minus 2 times 85, which equals 170 meters. So therefore our dimensions are 85 meters by L, or 170 meters. So once we have our area function, again, remind you, our vertex was 85, 14,450. The only thing left to do is find the domain and the range. So the domain is WER, and our range is YER, or area ER, such that area is less than or equal to 14,450. Don't forget your curly braces around it, and then we're done.